Alright, so I'm just going to show you a couple of these piecewise graphs. The 17 and 18 are rational functions, so hopefully you are a little more comfortable with those since we did a couple days on rational functions at the beginning of the unit. For 15, we have two little lines, and what we're asked here is the limit from the left. So I'm going to go ahead and graph what's going on here. This guy right here, negative x minus 3. So there my slope is negative 1 over 1, and my y-intercept is negative 3. So I'm going to start at negative, and this is only where x is less than or equal to negative 1. So what's helpful for me with that, what I like to do, is kind of put a little dotted line in my graph at negative 1, and I know this guy is just going to happen to the left of that dotted line. Okay, so again, I'm going to start at negative 3. My slope is negative 1 over 1. But here, once I have my pattern going, I'm on the wrong side of the line. So I started my pattern, and I'm going to go backwards. This is going to have a closed circle on that break line, which is really hard to see because I put gray on right here. So I want a closed circle when I get to my line going backwards. I'm just going to close circle on my line. My slope is negative 1, so it should be a downhill. And I'm just going to go back and erase anything that was on the wrong side of the line. So it does say the limit from the left. I'm going to go ahead and finish out the whole graph. Because I like to be thorough, it's good practice for us. For x plus 1, my slope is 1, and my y-intercept is 1. And I'm going to have an open circle on that break line. So I'm going to start at 1. I'm going to go up 1, right 1. I'm going to go backwards, and when I get to my line there, my yellow line, I'm going to do an open circle. So there's my piecewise function. Now let's talk about the limit. So what I was asked for is the limit as x approaches negative 1 from the left of f of x. So that's here. And where our graph is going as we get close to negative 1, our y value is negative 2. Awesome. All right, for 16, we're asked for the two-sided limit. So we're going to need to, since it doesn't have a little plus or a little minus, this is the two-sided limit. I'm going to go ahead and graph the easier part first. I know this guy here. So my break line is at 2. I'm going to go ahead and, or negative 2. That's why we're asked for the limit there, because it's the interesting piece of the graph. I'm going to go ahead and graph f of x is equal to negative 1. So here that's going to be an open circle at negative 2. And sometimes it's helpful to write that as y equals negative 1. So y equals is going to go through the y at negative 1. Since there are no x's there, I'm going to have a open circle at negative 2. I'm going to have a horizontal line because it's going to go through the y-axis at negative 1. The rest, negative x squared minus 4x minus 5. Yeah, that's not the vertex form, so that makes it a little more difficult for us to deal with. So I'm going to do a little table. So what I'm interested in is what's happening at negative 2 and maybe negative 3 and negative 4. And what I'm plugging into is that negative x squared minus 4x minus 5. Again, I really think the thing with limits is that the math isn't hard. Sometimes there's a lot of it. give us positive 16 when I square the negative 4, which is going to become negative 16. Negative 4 times negative 4 is positive 16. And then minus 5, that's all going to give us negative 5. That's lovely. So this ordered pair is negative 4, negative 5. Let me go ahead and put that on my graph. I'm going to do the same thing with negative 3. And precision here is important. You need to get the right values. So when I square negative 3, I got positive 9. That becomes negative 9. Negative 4 times negative 3 is positive 12. So negative 9 plus 12 is positive 3 minus 5 is negative 2. So that ordered pair is negative 3, negative 2. That looks reasonable for an upside down problem. Okay, negative 2 squared minus 4 times negative 2 minus 5. So negative 2 squared is positive 4, but I have that negative on the outside. Negative 4 times negative 2 is positive 8 minus 5. So negative 4 plus 8 is positive 4 minus 5 is negative 1. So that table really is absolutely reasonable to do. And sometimes with limits, you do just have to brute force kind of bust through a table. So that ordered pair is negative 2, negative 1. And that actually fills in that open circle. So that's what this piecewise function looks like. We were doing all of that to evaluate the limit as we approach negative 2. So let's look at that limit now that we have this beautiful picture. From the left, our curve is going to negative 1. From the right, our horizontal line is going to negative 1. So our limit as x approaches negative 2 of f of x is negative 1. Awesome. Now go ahead and try 17 and 18. They're rational functions, so you might have to do a little table work, but they're a little bit easier than all right, let me know if you have questions.